Let's take a look at proportion word problems. This is more at a 7th grade level here. Normally, you need to build a proportion to solve these. Certainly, you can do other styles to get the answer at times, but usually in 7th grade math, there's such a large emphasis on proportions that you need to build one normally, and it's in the directions. The other thing is one of the hints about these story problems is a lot of times they'll give you 3 numbers, and they expect you to go find the 4th number. And if you see that type of setup, usually that kind of hints at a proportional story problem. So let's take a look at this one. A flagpole has a 9-foot shadow, and a soldier standing next to the flagpole is 6 feet tall and has a 1-foot shadow. How tall is the flagpole? So again, they've given us 3 numbers, and we're expected to go find the 4th one. It usually helps to draw it. So draw your flagpole, okay, and label information that you know. I don't know how tall that flagpole is, but I do know that it has a 9-foot shadow. So I'll put a little shadow line down here just to kind of show that and label it 9 feet, and I'll probably put shadow. Now, the other thing is that there's a soldier standing next to the flag. So you can use a little stick figure or whatever and put in the information. He's 6 feet tall, and he's got a 1-foot shadow. So there we go. There's his 1-foot shadow right there marked in red. It doesn't have to be a real fancy drawing or anything like that, but now we can go ask ourselves this question: how tall is this flagpole? So from here to here is the height of the flagpole, and we don't know what it is, so I'll just label it as X feet. So this is the height of the flagpole, this is the flagpole shadow, soldier's height, and the soldier's shadow. And from here, we can actually build a ratio, okay? So if I put the soldier's numbers together, 6 feet to 1-foot shadow, and you'll see I even took the time to label that the 6 feet was how tall he was, or the height, and that the 1 foot was the shadow. I can put these two together as a ratio. Then if I come over and look at the flagpole, I know that one number's missing, but I've got the other, but we can still build a ratio, okay? So since the soldier's height was on top, I'm going to put the flag's height on top, which is unknown, and that's the X. But the flagpole shadow would match up with the soldier's shadow, so we'd put that on bottom. And if you take a look here, the units are on the same level, are the same. So shadows on bottom here, shadows on bottom over here. Tall on top here, tall on top here. And now it's just a regular proportion when we go and solve. So how tall is the flagpole? It's 54 feet tall. Now, you don't always have to draw a picture, and in case of, well, like this problem, a picture's not really going to help. So Eduardo bought 13 tubs of dried blueberries for $104. How many tubs of dried blueberries can Callie buy if she has $520 worth? Well, the first thing I would do is I would look at what 2 numbers we could put together to make a real quick ratio. And since Eduardo was tied into 13 tubs and $104, let's just make that into a ratio. And then the second part, Callie with the 520, that'd be like the second ratio. So build the one that's got both numbers, 13 tubs, $104, that's Eduardo. And now Callie, well, we're missing one, but we've got one, and we know the one that's missing is X tubs. How many tubs? We don't know, so we'll put that as an X, and tubs is on top over here. So we'll make the X tubs on top over here for Callie's. And then we know that she's got $520. We'll put that on the bottom. Now we just go solve. So Callie could buy 65 tubs of blueberries if she had $520. Now this one, again, it's not a great example of a drawing problem. It's kind of like the last one with Eduardo, but the exchange rates are pretty popular. So let's take a look at this one. The money used in Croatia is called the kuna. The exchange rate is $7 to 39 kunas. Find how many dollars you would receive if you exchanged 429 kuna. So if you went over there and you got some Croatian money, and then you decided to come back to the U.S. and you still had some Croatian money on you, you would probably want to go ahead and exchange that back to American dollars, because Walmart's not going to take kunas in place of the dollar. So you need to exchange 429 kunas, and we're saying how much money would you get back. So in the same way, you want to build the ratio that's given to you. The $7 is tied into the 39 kuna. This is the exchange rate, so you could build a ratio right there. And in this case, I've got dollars on top and kunas on bottom because that's just the way that they gave it to me. But it's not a big deal if you put 39 kunas on top and put the $7 on bottom. You're just trying to build that nice ratio, right here that's given to you. Okay. Now, the next thing that's happening though is that since as soon as you have this ratio set up, when you go build the second one, make sure you've got the $7 on top or whatever dollars are on top and kunas are on the bottom. So let's read the rest of the problem again. How many dollars would you receive? Well, how many dollars is that? We don't know, so we'll use an X there, but we will put it on top. Why? Because I had $7 on top here, and dollars need to be on the same row. How many kunas would be given? In this case, it would be 429 kunas, and so we put that on the bottom, and now we're ready to solve. So, how many dollars would you receive? You would get $77 if you gave them 429 kuna. Last one, we're going to do this one two different ways. That way you can see doing it without the drawing and with the drawing. Paul enlarged the size of a rectangle to a height of 435 inches. What is the new width if it was originally 15 inches tall and 2 inches wide? So let's do it without the drawing side. We'll do it on this side over here. You can see that 15 inches tall to 2 inches wide kind of forms its own ratio. They gave me 15 inches tall, so I'll put that one in first. 2 inches wide, I'll put that one in second. Now, you can see right here that the new size of the rectangle after Paul enlarged it was a height of 435 inches. So that's the height that's the same as tall right here, right? So I'm going to put 435 inches up top. And then they're asking you what's the new width. And so the width would go on the bottom one, and we'll make that an X. Now you just cross multiply and solve. And it would be 58 inches is the new width. Now if you want to do this problem and drew a picture of it, hey, pictures help sometimes. In this case, you could draw a rectangle, and I immediately am drawn to the original size, 15 inches tall, 2 inches wide, so it's a skinny rectangle. I'll label 15 inches tall and 2 inches wide, so here's the tall, here's the wide. And then I draw a bigger rectangle over here, and the new height is 435 inches. Now, this is not the scale, but I do make this one bigger because I know it's supposed to be a little bigger than this one. That also tells me that this width right here should be a little bit bigger than 2 inches here, okay? Actually quite a bit bigger. Now, how do you use this drawing to draw it? Well, I use these two right here because this is the tall over the width, and so 15 over 2 becomes a nice ratio right here, 15 over 2. And then because I put the 15 this way, because I put this one on top right here, I'm going to use the 435 on top for the second ratio, okay? And then the X would fall underneath. And hey, this is the exact same ratio you see right here, 15 over 2 equals 435 over X. So I don't need to go and solve it again. You'll get the exact same numbers, but it's just a different way of setting it up.